Hi there, welcome to SVS 201. My name is Emily Shea, and I'm super excited to be talking to you today about getting started building your first serverless applications. The target audience for this talk is really anybody who has an application idea that they're really excited about and want to get started building. You might be someone like me who's relatively new to coding and is just looking for a way to build the application that they have in mind. Or you might be somebody with a lot of coding experience, but maybe you've built applications that run on servers or containers before and are looking to explore serverless. Either way, I'm hoping to take you through my serverless learning journey, how I went from not knowing a lot about serverless to building my own applications, and share some of the tips and things that I thought helped me along the way. So to tell you a little bit about me, my name is Emily Shea. I'm a serverless go-to-market specialist based in London. I lead go-to-market for EventBridge and step functions, and I spent about 5 years at Amazon. I come from a non-technical background, so I majored in Chinese language in college, but I got into coding around 2018. I was getting up to speed in AWS, doing a lot of tutorials, and I thought it'd be fun if I could actually get in there and code and build my own applications to solve some of the things that I was thinking about. And I had a lot of fun with it, and so I've been coding as a side hobby for the last couple of years. The content that I'm going to take you through today is really taking you from the ideation, so figuring out what I wanted to build and the application idea that I had, choosing serverless for that application, then through my learning process, so what resources did I use, what services did I get started with, and then finally to the application that I built. And I want to take you through the different phases of architecture that I built because it's evolved over time as my skill set has evolved. So this is the application that I wanted to build and the need that I was looking to solve. I mentioned that I studied Chinese language. I studied it for many years, but I was finding that I was falling out of practice a bit. And so I was looking for a way to kind of bring it back into my daily routine. So the app idea that I had was to send myself and possibly others, if they're interested, daily messages with a new Chinese vocab word and just a bit of a reminder to practice. So these are the requirements that I have for this project. First off, I had just started coding when I took on this project. So I just had some Python and some JavaScript to get going with. I also wanted to use this project as a learning tool, so to maintain and expand it with new features over time. And lastly, this is a side project, and so I definitely want it to be inexpensive, low operations and maintenance needs over time, and if possible, if it can scale without me needing to think about it. So no matter what the traffic that comes into it, it's able to handle that, scale up and scale down. These would be awesome features to have. So why did I pick serverless for this? Just to define serverless, serverless is about running code without managing any servers. So in the past, if you had an application idea or wanted to build a website, you would need to spin up a server. You need to patch and update that operating system. You would need to pay for a fixed amount of capacity. Say that your traffic is only about this much, but you still might need to over-provision that server just in case. Because what if the traffic spikes? Maybe it spikes even more than the capacity of the server that you provisioned. Then you might need to scramble and spin up a second server and figure out a way to load balance the traffic across those different servers that you've got. And there's just a lot of things that you need to learn and things you need to manage that's just on the infrastructure level. That's not even thinking about the actual application that you built. And so what serverless does is it takes all of those server management tasks and it hands them over to AWS to manage for you. So then you're just focusing on the code and the application that you're building and the features that you want to build within your project. When you're building with serverless services, you get some really cool features built in, like completely automatic scaling. So you never think about needing to spin up new servers or to have more resources. That happens completely in the background without you needing to worry about it. That means that you've got built-in high availability. So your application's always up and ready for users to reach it. You've also got an awesome pay-for-use billing model. So you're only paying when your code is running. Which can be a cost savings if you have some cycles of traffic and some time when you don't have as much usage. So let's look at how serverless matches up with the requirements that I had set out for this project. First off, I mentioned that I'm just bringing some coding skills to this project, so I don't have a background in managing servers or any of those maintenance tasks. And so this was appealing to me because I didn't necessarily want to learn that piece before I could go out and build my application. I also wanted to build and maintain this application over time and expand it. And serverless, with serverless, you're building microservices and a lot of reusable components that you can build and iterate on over time. Lastly, I think serverless definitely fits that need that I had for having a low cost and really zero maintenance application and that built-in scalability. So now that I've got my app idea, I've chosen serverless as the best way to build it. Now I want to take you through how I learned to build with serverless. So you might have opened up the AWS console, gone into services, and seen just a huge catalog of services to potentially pick from. It can be a lot, and you want to kind of narrow down, okay, which one do I pick up first? Which one do I start with? And so I wanted to provide my serverless learning path as an example for a way to kind of slowly build up the services that you're comfortable with and using in your applications, and to show you kind of the ones that I thought were helpful to start with. So probably the first thing that I touched in AWS was Amazon S3, just for storing files, maybe hosting some static websites. So you can throw some HTML and JavaScript into an S3 bucket and host a website off of that. So that was a nice one to get started with. Then I started to use Lambda functions. So Lambda functions allow you to run code in a serverless way. And so I started putting some Python code into Lambda functions. Once I had some Lambda functions and some data in that S3 bucket, I started to play with some integration services. So things like simple notification service, or SNS, that sends text messages or emails. I also looked at EventBridge. EventBridge, I used something called like scheduled events to trigger those Lambda functions. So I could set up an EventBridge event that would run on a daily or a weekly cadence to trigger my Lambda function. I also used step functions. So step functions allows you to build workflows with the different pieces that you've got of your application. So say that you want to have a workflow where you trigger this Lambda function, then this Lambda function, and then depending on the result of that, one of two different SNS messages get sent. And so step functions will allow you to orchestrate all the steps within that flow. The next pieces that I added on were APIs. So as I set up a front-end website and I wanted to have front-end users interact with the back-end, I needed API endpoints for them to be able to request data or update data. I also added DynamoDB into my application as a serverless database to have some more advanced database and storage capabilities. And then lastly, the last couple of services that I've added into my serverless stack have been AWS Amplify and also Amazon Cognito. So I'm using these services. Cognito has some great capabilities for managing users, so usernames and passwords and all of that functionality, to be able to add some user profiles and authentication into my serverless stack. So these are the services that I kind of tacked on one after another and slowly started to build expertise with. But the services that you choose might depend on the application that you want to build. Maybe you want to add some image recognition, and so you'd like to call Amazon Recognition in there. Or it could depend on your skill set that you're bringing. So if you're someone with a lot of background in front end, for example, AWS Amplify might be really comfortable for you to get started with. But the reason that I picked these services is that coming together with just these 9 services, you can build some really powerful and exciting applications. So I think that these services together make for really robust and full stack serverless applications. And you can get a lot done, and a lot of the web applications that you might be thinking about, you can build with just these services. So I've talked a bit about services. Now I wanted to touch on the developer tools that I found help me be successful with serverless. So first off, one of my favorite things to do to get comfortable with the service is just to experiment within the console. You can go into the AWS console, start to see some of the features, just experiment with what it looks like to set up that resource. And I think it's a great way to get comfortable and get started with services. But you might find, like I did, that it's really not sustainable to be setting up things in the console when you're starting to build more larger scale applications. I found that I might set something up and then forget how I had configured maybe the settings for a Lambda function, and so I wanted to create a similar Lambda function. It was a bit of trial and error and just some confusion around how to kind of set things up, and so there was a lot of I was missing some of that consistency in my experience of deploying new resources. And so I highly recommend, as you're getting into moving away from tutorials and getting more into building your own applications, that you get started with an infrastructure as code framework. So rather than going manually into the console and setting up a Lambda function, an infrastructure as code framework will allow you to define all of the resources, your functions, your S3 buckets, all of those things as if they were code. And so you've got the resource configurations all written out. Every time that you deploy that framework, those resources are going to be deployed the exact same way, which allows for a lot of consistency, repeatability of deploying your applications. There's a lot of great options for frameworks to choose from when you're building serverless applications. One of them is the AWS Serverless Application Model, or AWS SAM. There's also the Serverless Framework, Terraform, all of which will give you some great reliability as you're deploying applications. So in addition to an infrastructure as code framework, the other thing that I found really valuable as I was getting started and starting to build more applications was setting up an automated deployment pipeline. So when I first started building applications, like I mentioned, I was using the console a lot, deploying things manually, but I was also writing my function code manually into the console. Maybe I would write it directly and then save it within the console, or I might write it within a text editor and copy some of those changes over to the console. And I find whenever you're doing anything manually, whenever you're pressing buttons, the risk of something going wrong is just increases more and more. And so I might forget to save something, or forget I made a change over here and wonder why it wasn't working correctly over here. And so I think those kind of issues will get kind of frustrating and slow you down as you're building. And an automated deployment pipeline will solve a lot of those issues. So to take you through what an automated deployment pipeline looks like, the first step is working in your text editor. You're writing up the resources that you want to build in your serverless framework of some kind, and then you're also writing up your function code. And once you're ready to deploy a new version of that application, you take all of that code and you check that code into something like code commit or some kind of repository. And the repository is going to be your version control for your application. So it'll save every version that you've got. You can go back to older versions, and it's just a nice, secure way of making sure your code is saved down. Once your code is saved to the repository, that will trigger a new build process in your pipeline tool, something like AWS Code Pipeline. And Code Pipeline will take all of the new code and it will package it up and push it onto the cloud. And suddenly your code is live, your website's updated, everything is great. And so it's a really seamless process to just stay in your text editor, make any changes that you want, and get that code deployed automatically without messing around and making any manual changes and having room for error. So thinking about some of the actual content and resources that I used as I was going through this learning journey and setting up my pipeline and getting started with those services, I definitely spent a lot of time with AWS blogs and tutorials. And what I've done is on this QR code and on the link right below it, you'll find the resources page for this talk. I've got the slides here. But I've also got kind of a curated list of the different blog posts that were helpful to me, some of the tutorials, so you can kind of follow along the same journey as I did with picking up those different services. I also found that community-written blogs were super helpful. So I find it really great to just see what other people are building, check out their example code, look at their maybe snippets from their frameworks and see how they're defining resources. I think that's a really great asset that we can all take advantage of and also contribute back to in blogging and producing our own open source code. If you're looking for a great place for all kinds of curated serverless content, serverlessland.com is a great place to look, where the AWS developer advocates are collecting and curating all that content. And then lastly, as I was building with DynamoDB, I found that the DynamoDB book was a really good resource. So this was written by a serverless hero, Alex Debris. It's got a lot of great content on just some of the key concepts of Dynamo and how to go about designing your tables. And of course, I can't recommend enough doing some tutorials, but then going out and building something yourself. I think that really helps kind of cement the knowledge and also gets you so much more excited. And I feel like I stuck with it so much more when I had a project and a problem that I was solving myself. So now let's jump into the actual application that I built. So I'm going to take you through 3 different phases that it was in and talk to you a bit about the kind of tips and tricks that I use that I'd recommend throughout. So the very first phase of my application, really the kind of lightweight MVP that I built, was just around sending text messages to myself. So the first piece of this is I've got Amazon EventBridge that's sending a scheduled daily event that triggers a Lambda function. This Lambda function pulls from S3. I've got a CSV with a long list of Chinese vocab words. It picks one as the word for that day, and then it sends it through SNS and sends myself a text message. I want to give you a peek into the function code that's powering the application at this point. So this is the function, this is the code within that Lambda function that's pulling from S3 and sending to SNS. I'm using Boto3, which is the Python SDK to interact with different AWS services. I'm instantiating my S3 and my SNS client so I can interact with those services. I've got a Lambda handler that's going to be triggered every time this function is invoked. There's a comment there where I would call out to S3 to retrieve the vocab words. I'm assembling the message that I want to send. And then I've got some error handling wrapped around my call to SNS to publish that message. Within SNS, I've got a topic, so that's target ARN is the topic ARN within SNS, and then I've got my phone number subscribed to the topic to receive the messages. I also wanted to show you the SAM template. So this is the infrastructure as code framework for how I defined the Lambda function for this application. And so I wanted to point out a couple cool things that SAM does for you that allows you to define your serverless applications really concisely. So the first thing to look at, so I've got in resources, I've got a send text function. You can see I've got policies there, and I've got an SNS publish message policy. And so what this is doing is it's attaching that IAM policy, and it's giving this function the permissions to be able to make that call to SNS. Below that, I've also got a section for events, where I've got the daily event bridge event that's set up on a schedule. And this is all of the configuration that I need to be able to create that event bridge event and attach it to the Lambda function. So that was the very simple start of my application, very straightforward and kind of quick to get set up, but all it's doing is sending text messages directly to me. When I was talking to some friends that also studied Chinese, they thought that it'd be really cool if they could sign up to the service also. But there was a lot of work that needed to go in before it was really ready to make it a public-facing service. The first thing that I'll need is a way for other people to subscribe. So I don't want to have to manually add their phone number, email address, or whatever else to that SNS topic. I'd like to have a website that they can come onto. I'm also going to need an API for that website to use to be able to interact with the backend of my application. And then finally, I'm going to need some way to manage my subscriber data. So how do I store the contact information for my subscribers and make sure that they're all receiving that daily message? So this is what the second phase of my application looked like. The right side of this architecture diagram is mostly the same from the first phase. The only change that I've made is I've swapped out SNS for SES, because I found that there was a bit of a cost savings if I moved from sending text messages just to email. So that's simple email service. And then the left side is all brand new, all to support this kind of public platform or public website that I want to build for this application. So the first piece is setting up AWS Amplify to host my static content. So I've put my HTML and JavaScript, so they're going to make up my website, and Amplify is hosting that. The next piece that I've got is Amazon API Gateway. And API Gateway is providing those endpoints that are sitting in front of my Lambda functions for users to be able to subscribe or unsubscribe themselves. And those subscribe and unsubscribe functions are interacting with my DynamoDB database that's storing all of the contact information. So all of the users' email addresses, the Chinese vocab level that they're subscribed to, all of that stored in DynamoDB. And the function that sends those daily words out is going to pull from that database to get that contact information. This is the front-end website that I built. I used the Vue.js framework to build this one. And you can see the form that I've got here where it says subscribe to receive daily vocab word emails. I've got a little drop-down where they can choose the level of Chinese that they want to subscribe to, and then a form where they can put their email address in. And when they hit subscribe, that's going to take that email address and information and send it to the API endpoint and update the DynamoDB database. I want to tell you about something that I did at this stage as I was starting to add APIs that I thought was really helpful, and that was just to write some really simple API documentation for myself. So you might be, and I think this was actually really helpful just in the context of this is a side project. So I might work on it for a while, leave it for a couple weeks, and then come back to it. And so if you've ever had that feeling of looking at code that you wrote a while ago and saying, who wrote this, because it can't be me, I think that this was a really helpful strategy to make sure that I was kind of remembering and keeping track of what my APIs expected as an input and an output. So this is what some of the API documentation would look like. I've got a short description of what the API endpoint does. This one is an API endpoint that I made that saves all of the past vocab words that have been sent out, so users can go in and review words that they've seen in the past. Then I've got my query string parameters. So this is what you would use to call that API endpoint. So I want to remember what the format was for the data that I sent to that API endpoint, just so that I know what it expects to see. And then lastly, I've got the API response. So this is an example response that this API would send back to whatever service called it. You might have noticed in the architecture diagram that I added in DynamoDB in this iteration of the application. And I wanted to talk a minute about the kind of iterative approach that I took to storage and database components of my application. In the first phase of my application, I really kept it simple and just used S3 and just storing flat files in S3. So I had a CSV with all of the Chinese words stored in S3, and the Lambda function was pulling from that. But as my application got more complex and I had some more complex needs for databases like managing subscriber contact information, I started to use DynamoDB. But I think the approach that I took with DynamoDB was just based on my existing experience using a bit of SQL. And so I really treated it like a SQL database. I created tables for each of the different types of data that I had and just kind of used it in what kind of felt intuitive to me at the time. As I was thinking ahead to the different features that I wanted to build and the functionality that I wanted to add to the application, I started to see how the way that I had set up my tables in Dynamo really wasn't going to be very conducive to what I wanted to build. And so while I had gotten away with treating DynamoDB like a SQL database at a small and simple scale of my application, I saw that there was room to really optimize for what makes DynamoDB unique. Because as a NoSQL database and a key value store, there's different considerations when you're designing a DynamoDB table. So what I did in the third phase of my application is I took a step back, took a look at my access patterns and the things that I wanted my application to do with data, and I redesigned my DynamoDB tables. So I moved from having multiple tables to just a single table. I grouped data that I wanted to grab at the same time together, and just thought a bit more ahead about the table design that I wanted to have. I think this approach worked, this overall flow of learning worked for me, just given the fact that I was kind of building up that expertise, starting to learn about databases in Dynamo, and now I understand a bit more about what makes DynamoDB different and kind of a unique data store. But I think that if you do have a bit of experience with databases and want to learn a bit about DynamoDB, I think you can absolutely save yourself a refactor and save yourself a bit of work. And spend a little bit of time thinking about your access patterns and learning about DynamoDB table design ahead of time. So that was phase 2 of my application. And I've kept it pretty simple when it comes to the kind of information that users are providing me and their ability to interact with my application. So in phase 2 of my application, they really just gave me their email address. I started receiving emails, and that was kind of the end of it. But I saw a lot of opportunity to expand what they're able to do in the application. But the first step for that would be to give them the ability to create a user profile. So I wanted to add cool features like allowing them to go in and manage this list subscriptions, or maybe in the future I could add ability for them to take vocab quizzes and to store those results and to see how their progress is shaping up over time. All those features would require me to add user profiles into the application. So this is what the current phase of the application architecture looks like. Everything has stayed the same except for what's in the dotted line box. So I've got Amazon Cognito, and Cognito has a lot of functionality that helps me manage my users, so keeping their usernames and passwords, and it acts as an authorizer for those Lambda functions. So these Lambda endpoints are kind of protected routes within the application, and so if a user comes onto the website, they have to be signed in order to get or update their user data. And then be able to interact with that data within the DynamoDB table. These are the front-end interfaces that I built in front of those new API endpoints. This is my user profile page that you're looking at. The first screenshot that I've got here is of the profile homepage. So I've set a little username in Chinese. I've got an avatar, and then I can see the daily words for the list that I'm subscribed to. The middle screen is the profile setting page, so I can go in and I can update my profile name or the emoji that I want, or my character set preference. And then lastly, I've got the user interface for managing my subscriptions. So at this phase of my application, as the Lambda functions that I was writing started to increase, I just had more function code around. There's a couple steps that I took to manage my function code a little bit better. One of the things that I did was start to use Lambda layers. And what layers allows you to do is it allows you to abstract common code that multiple functions need to use and put it into a layer that you only have to manage in one place. So for example, I've got two different functions now that both need to retrieve user data, like the profile name and the date that the user was subscribed. So I've taken that Python module, I put it into a Lambda layer, and both of those functions reference it, and that Lambda layer is deployed up with both the functions. And I found this to be a nice way to not have to duplicate code within functions, just be able to manage and test it once, and just simplify my code base a little bit. Another thing that I've done with my function code that I feel like helps me build so much faster is unit testing my function code. So prior to this, what I would do to test that function code is I would write up some function code, deploy it through my automated pipeline, and then I would go check it out in the console, and there's a little test button within the Lambda function console that you can test and see what that function returns. This was working great initially, but I think as my application got larger and it took longer to deploy, I could be waiting for a couple minutes before a new version of my code is uploaded. And it can be really frustrating to wait for a couple of minutes only to find that you spelled a variable name wrong and it was just a silly mistake that you should have caught to begin with. And so to get around that and to be able to catch those, I started writing unit tests to be able to run some quick local tests on my function code before I need to go through a full deployment cycle. So here's what an example of a unit test for one of my functions looks like. I'm using the Python unit test framework. And the thing that I'm doing here that's interesting is because I don't want to interact with the AWS APIs, I just want to run this test locally just to check that the code that I've got is going to work out. There's some limitations, like I can't see what maybe the exact output from an AWS API might be. And there's some great content that other folks have written about kind of testing from more of an end-to-end perspective. But just to text the function code locally, I've mocked my calls to S3 and I've mocked my call to SNS so that I can kind of fake the responses to those and just test the rest of the code. So I've got some mock responses from those different service calls that I would make. Then I've got my function test down below that, and I'm doing a test build, and I just have a couple simple assertions here. I want to make sure that this makes a call to S3 once, and it makes a call to SNS once. And that'll just let me know if the code is working like I expect it to, or if it's going to throw a syntax error or something simple like that. Another thing I want to touch on is I found that it's really cool, it's building with serverless services, is that I've been able to add a lot of features onto my application and expand it over time, often without needing to make a ton of code changes to the existing application. And this is a particularly example of that because I made 0 code changes to the base application when I was adding this feature on. So with this feature, I wanted the ability to take a look at what my subscribers were doing in aggregate. So basically say, how many subscribers do I have? Has it changed week over week? And just have some stats on my subscribers overall. So what this architecture does, first I've got my DynamoDB table that has all of my subscriber data in it. Then I've got a Lambda function, and this Lambda function is triggered by an event bridge event on a weekly cadence. So say every Friday, this Lambda function is going to do a full scan of this DynamoDB table. It's going to take that data and put that snapshot into S3. Then QuickSight, which allows me to visualize the data, is going to pull that updated data from S3 and create some nice visualizations. Here's what some of those visualizations look like. I can see my subscribers, my subscribe and unsubscribes over time. I can see that I've got 105 unique active subscribers, and I got 2 new subscriptions last week. And I can also see that most people are subscribed to, or many people are subscribed to level 1, and the majority of people are subscribed to simplified Chinese characters versus traditional. So just some cool insights that I was able to get without any code changes to the base application. The last thing that I wanted to mention is just around monthly costs to run the application. I mentioned that with serverless, you're only paying when your code is running. And so in my application's case, it made a ton of sense just because it's a very kind of scheduled basis. So I'm only sending those emails on a daily basis. I've thrown up some numbers here just to give you a bit of a sense of the scale of the application, a little over 100 active subscribers. So if you had to guess how much you think that this application would cost to run on a monthly basis, would you put it at maybe over $5 per month? Maybe something under $5, or maybe under $1, something in that range? So it is 82 cents per month to run, and most of that goes to Route 53 for a hosted zone for my domain name. And the cool thing is that you'll see a number of these services are actually below the free tier. So you can get a lot done with a lot of these services because they do have a pretty substantial free tier. So my application is very cost effective, I would say, to run on a monthly basis. So we've taken quite the journey through taking you back all the way through my serverless learning experience, through the different architectural evolutions of the application that I've built, and just that I've had a lot of fun learning and getting to build. So the takeaways that I wanted to leave you with, first off, serverless has been awesome to experiment with new ideas and to just build applications quickly. When you're not managing servers, when you've got a lot of awesome managed functionality built into those services, I think you can get a lot done and build your application really fast using these tools. Along with tutorials, I found it so much more exciting and so much more really solidifying my understanding to build my own applications and solve the problems that I was thinking about. So I thought that was a much more fun way to kind of learn and get into it. One tip that I really recommend is just around that deployment workflow. So getting your infrastructure as code framework, kind of using that to build applications, and then also setting up that automated deployment pipeline. I think you'll be amazed at just the how much faster you're able to build and how much how much smoother it is to get those applications built and deploy new versions. So that's something that I recommend investing in early. And then finally, as you've seen through the different architectural evolution from a single Lambda function to a bunch of Lambda functions and visualizations and all these different things that I've been able to add to my application in the end, I found it to be really easy to expand and to add on to as I've grown my own skill set. So to leave you with a couple resources to learn more, I've thrown the QR code up again. That is the resource page for this entire talk. You can find slides, all of the different blogs and tutorials that I'd recommend if you want to kind of follow along with the services that I got started with. I've also got the links to my blog and my Twitter, where I've talked a bit about what the process was for building this application. And then I've also got the open source code. So all of the code that's backing up the application is available right there. Of course, this is my personal side project, not affiliated with AWS, but you're welcome to check it out. And then, of course, serverlessland.com is a great place to look for new and upcoming serverless content.